Next little mini skill is writing net ionic equations. So what we are looking at is kind of the thing that's driving the reaction. So you're going to start with a balanced molecular equation, just like we did in 0.13. Then you're going to write the full ionic equation, and then you're going to cancel out the spectator ions and be left with the net ionic. What's left is the actual chemical change that occurred. Everything else is what we call spectators, right? They're not part of what's driving the reaction. Some tips: only aqueous compounds can break apart into ions. You can use a solubility chart to decide if a product is solid or not. We aren't going to review that here, but that is something that you're going to be aware of when we get into the Chem 60 stuff. And then the net ionic equation shows only species that change during the reaction. So really what we're going to do is we're going to take this and break it apart. So any of the aqueous species are going to be broken up into their ions. When you have subscripts, that tells you how many of that element you have or how many of that ion you have. So I'm going to have 2 potassiums. When you write it as an ion, you want to put the charge. And I will also say that this takes a lot of room, so I'm going to start farther over. So I'm going to say that there are 2 potassium plus, and then it's still aqueous. So if you break up aqueous, this is an aqueous ion. And then I'm going to have just 1 of these chromates. Now its charge is going to be 2 minus. I can know that just by the way the formula is written. I know that potassium's 1 plus, so I know that I did the crisscross and I ended up with a 2 minus. If you didn't, you can always go over here, look up chromate. There it is, 2 minus. Okay, and then I'm going to have barium. Again, same reason, it's going to be a 2 plus. And then I have 2 nitrates, which charge is -1. And then the solid doesn't get broken up into ions. It is precipitated out of the reaction as a solid. And then I have this 2 out here. So that's showing me that I have 2 of everything in this compound. If there were subscripts as well, so if this was like K2, you would have 4 potassiums, but I just have 2 potassiums that are aqueous. And then I have 2 nitrates. Now, this is kind of a nice way of checking to make sure that your equation is balanced. When you go to get rid of your spectator ions, you have 2 potassiums and 2 potassiums. You have 2 nitrates and 2 nitrates, right? So everything is balanced left and right from an ion standpoint. Then, what's left? Well, what's left is the chromate and the barium going to barium chromate. All right, and then we look to see what's left. So we've got the chromate, 2 minus, aqueous, plus the barium, 2 plus, aqueous, forms that solid barium chromate. So the thing that drove this reaction is the formation of a solid. Now I always have a tendency to want to write it as barium plus chromate goes to barium chromate. I just wrote it the way that it exists. If you had them switched, that's fine. I also find that I get kind of bored of these, that I don't often, like if it just asks me for net ionic, I don't always include that middle step. So sometimes I'm like, well, what makes the solid? Oh, barium and chromate. And then just make sure that everything is balanced and you're good to go.